What factors can affect cardiac output? Tell me. Already we saw, na? There are two factors over here. First one we can say stroke volume. Okay, how it is affecting? Increase in stroke volume increases cardiac output. Decrease in stroke volume will decrease cardiac output. Isn't it or not? And the second thing we can say, heart rate. Okay, increase in heart rate will increase or decrease? Increase cardiac output. Similarly, decrease in heart rate will decrease cardiac output. Okay. Then cardiac output may also depend upon contractibility. See, contractibility in the sense, if the muscles of heart, they contract at a rapid rate and they contract more, cardiac output will be more or less, tell me?
More, sir.
More, right? See, increase rate and intensity of contraction of muscles of heart. See, if heart is contracting fast and more, what will happen? Increases, it will increase stroke volume. Na? Yes. More blood will be pumped out. More blood pumped out means stroke volume will increase. Thereby, it increases cardiac output. So we can say contractibility it is directly proportional to cardiac output, isn't it? It is directly proportional to cardiac output. The next one we have is afterload. Afterload means it is the pressure in respective arteries after ventricular systole. Means, for example, we know that when the heart is pumping blood, it is blood is entering into the artery, pulmonary artery as well as systemic artery. And when the ventricles start relaxing, semilunar valves, they close, right? Semilunar valves, they close. Pressure in the ventricles will decrease. Hello? If the pressure in the ventricles is decreasing, who is this? Sai Krishna, remove him. Any? Remove. Who was this? What was his name? Akhiranandan. He went away. You removed? Okay, good. Don't report him, otherwise he cannot join ever. Never he can join then. If we report, it will be better, I guess, next time onwards, if people creating such a nuisance. You have to take quick action, Mr. Sai Krishna, when you are a co-host. You should either mute them or else remove them. So pressure in respective arteries after ventricular systole, we are saying, right? So see, when already blood is pumped into arteries, certain pressure there in the arteries or not? But the ventricles, when they undergo relaxation, the pressure will be low. Now during the second cycle, if we need to pump blood again, we have to open the semilunar valves or not? During the second cycle, if you need to pump blood again into the arteries, we have to open the semilunar valves. So in order to open semilunar valves, we have to exert some pressure. With some pressure only, the semilunar valves will open, right? That is because of ventricular contraction. When the ventricles are contracting, blood will push open the semilunar valves and then blood enters into the arteries. Okay, but what happens is, if in the arteries the pressure is more, from ventricles, more pressure is to be applied. Okay, now tell me, now you know the relation. Now tell me, after load, is it directly proportional to cardiac output or inversely proportional? If in the arteries pressure is high, in the ventricle pressure is same, will it pump same blood?
No.
For your information, I'll just tell you, normally in arteries, in case of arteries, 80 mm Hg pressure will be there, and ventricles, they pump with 120 mm Hg. This is for aorta and left ventricle. Okay, so what is the difference? 40 mm of Hg difference. This is enabling 70 ml stroke volume. Okay, because of this 70 ml stroke volume is pumped out. Okay, let us say condition 1. Okay, in artery 90 mm Hg, the diastolic pressure has become 90. In ventricle, same 120 mm Hg pressure. Okay, difference will become how much? 30 mm Hg pressure difference. Will it pump 70 ml? Stroke volume will reduce or not?
Yes, sir.
Okay, so because of this, what we can say, after load is inversely proportional to cardiac output. Because stroke volume is decreasing, cardiac output will decrease. So it is indirectly proportional or inversely proportional. Increase in afterload, there will be decrease in cardiac output. Decrease in afterload will increase the cardiac output. Got it? Similarly, one more thing we have, preload. Preload is nothing but venous return. Preload is related to venous return. Okay, so it depends upon how much veins are bringing blood into the heart. Remember, if preload increases, cardiac output also increases. If there is more return of blood to the heart, in a heart more and more blood is returning, it will pump also more blood or not? So preload is, we can say, directly proportional to cardiac output. So this is a small overview related to the factors that affect the cardiac output. So that are the stroke volume, heart rate, contractibility, afterload, preload. So the relation between the contractibility and cardiac output, it is actually called as Frank-Starling law. Okay, not like what you learn in your higher studies. Don't worry about it. Okay. Next, now we can discuss things related to ECG. Give the next heading ECG. Here we are talking about electrocardiogram. Okay, electrocardiogram. Keep one thing in mind. Generally, gram means machine, graph means diagrammatic representation, but here in case of ECG, it is different. Electrocardiogram is graphical representation. Graphical representation of electrical activities that occur in the heart during cardiac cycle. During the cardiac cycle. Okay, whatever electrical activities occur in the heart during the cardiac cycle, that can be represented as a graphical representation that is called as electrocardiogram. Okay, and electrocardiograph is an instrument to measure ECG. To measure ECG, electrocardiograph will be used. Okay, and this ECG, if you see, ECG was developed by Einthoven. Okay, by Einthoven, and to obtain a standard ECG. To obtain standard ECG, if you need to get a standard ECG, body is connected to 3 electrodes. Body is connected to 3 electrodes. It is connected to 3 electrodes. Okay, so left. Okay, in the
Sir, you're muted.
there was a disconnection. I'll share the screen once again. For advanced ECG, multiple electrodes are connected. Connected to body. Okay, these 3 will be there. Along with these 3, to abdomen, chest, etc. Okay, around 12 electrodes can be connected in case of advanced ECG. Okay, so what happens whenever this standard ECG is taken? Okay, these three electrodes, okay, they form a Inthoven triangle around heart with respect to the circulatory pathway of heart. Okay, imagine that here we have the heart. Okay, circulation, if you see, with respect to subclavian artery, it goes to the left hand and right hand. Okay, as well as when you see, it goes to the legs also, with iliac artery as well as left and right iliac artery. Okay, so let us say this is the body and how circulation occurs. So if you connect an electrode over here, left wrist, right wrist, left ankle. Okay, so what is happening over here? It is forming a triangle. This is inverse triangle we have to draw. See, in this way, or else 1 second, first I'll draw the triangle somewhere else, then you put it over here. So in this way, it is forming a triangle. Okay? Triangle around the circulatory pathway of heart. This triangle, we can call it as Inthoven triangle. Okay, so now what we'll do is we'll see standard ECG, how it looks like. I have an image which we will just explain over here. See, this is a ECG with respect to time, and what all things can you see. Okay, so see, there are certain waves. Can you look over here? There is one P wave. P wave is there. Then there is a Q, R, and S wave, and then another T wave. In this way, P, Q, R, S, and T. Okay, P is one wave. Okay, so here remember the P wave. P wave, it represents depolarization of atria. When the SA node gives the signals to the wall of atria, P wave is obtained. Okay, depolarization means, remember, electrical excitation. Okay, so after the peak of P wave, after peak of P wave, atrial contraction begins. The beginning of atrial contraction occurs after the peak of P wave. Okay, I will show you from where to where contraction of atria is. Okay. Then what about the QRS wave? The QRS wave, it represents ventricular depolarization. Means excitation of ventricles, electrical excitation of ventricles. Means just after the QR segment. Okay. After QR segment, what happens? Ventricles undergo contraction. So ventricular contraction begins. Okay, just after R. Next, if you say there is another wave called as T wave, right? T wave, if you see, it represents ventricular repolarization. See, repolarization means again coming back to the normal state, return from excited state. Again, they return back from the excited state, that is repolarization. Okay, they return back to their normal ground state, right? So that is represented by T wave. So remember, at end of T wave, what will happen? Ventricular diastole or relaxation begins. Means if it is not excited, again it will come back to the ground state, right? Isn't it? When it is exciting, contraction is occurring. If it is not excited, what will happen? It will undergo relaxation. So after T wave, it will undergo relaxation. Understood? Did we see repolarization of atria? We had depolarization of atria, depolarization of ventricle, and repolarization of ventricle. Did we see the repolarization of atria? Tell me, did we see that?
No, sir.
No. Remember, the repolarization of atria is not seen in graph. It is occurring, but it is not seen in graph. Why? Because remember when we saw the cycle, cardiac cycle, when atrial diastole has begun, at the same time, there was another process that started. Tell me, what was that process? If you see the cardiac cycle, I'll come to the cardiac cycle again. Over here, we'll bring back the cardiac cycle. See the cardiac cycle. First 0.1 second was atrial systole. After that, for 0.7 second, there was atrial diastole, right? So, which process is coinciding with atrial diastole?
Sir, ventricular system.
Ventricular system.
Right? Okay. So, say when the atria is undergoing repolarization, okay, because it is masked by ventricular depolarization. So returning back of atria, at the same time, ventricles were excited. So we got the wave of ventricular excitation. So during this QRS wave only, atria was undergoing repolarization, but that wave was not seen. Got it? Got the point? Now look over here, friends. Within this graph itself, within the same graph, I will show you from where to where From which point to which point you have systole and diastole. Okay, so if you take from here, where did it go? This blue color line you can see now. Another line I will draw somewhere near here. Okay, so between these two blue lines is atrial systole. Okay, atrial systole. Now, just after R, what is starting? The ventricular systole will start. Okay, so from here till here, you can say this is ventricular systole, and from here till the next mid of P, we can say this is joint diastole. This is the joint diastole. Okay. Now there is one point given in your NCRT. In NCRT, there is one point given that end of P wave. End of P wave is the end of systole they have given. Which systole is ending at the end of T wave? Tell me. See the diagram now and tell me.
Sir,
Ventricular systole, right? So what happens is people just they see the NCRT and read the NCRT line and they get confused. They think that P wave is depolarization. They confuse depolarization with systole. Don't say that P wave is contraction of atria. After the peak, then contraction is occurring, right? If you take depolarization as contraction, repolarization as relaxation, then T wave is repolarization. It should be relaxation, ventricular diastole, it should be, right? But what it is? What is the T wave? At the end of T wave is ending. After T wave, diastole is beginning. Got the point? Okay, so here I'll just write one point that end of T wave, is the end of which is systole?
Ventricular systole.
Ventricular. This you make a small change in your NCRT also because they have mentioned only systole. You make it as ventricular systole. Okay, so that thing you have to be with. Here we'll make again one ECG so that with this point itself you have the clarity. Next P wave. Okay. Okay, so this was the P wave in this format. Then there was a Q wave. There was a peak of R, right? Then there was a depression of S in this way, and then there was T wave in this format. Similarly here, a P, then Q, R, then S and T. So this I'll just label it as P, Q, R, S, T, another P. Okay. And the demarcations we can take from here. Okay. Then over here, Okay. Then just at the end of the wave, next wave from here. Okay. So from this point, this is what? Atrial systole. From here to here, it is ventricular systole. And from here to here, it is the joint diastole. Now tell me, the sound will be heard when the ventricular systole begins, right? At this point, you will hear the lub sound. And when the diastole begins, here you will hear the dub sound. Okay. So first heart sound and the second heart sound. Got it? And we can say from 1 hour to another hour, RR interval also we can call it as one cardiac cycle. Also we can call it as one cardiac cycle. Isn't it? And tell me, by counting the number of QRS waves, if you count how many QRS waves are there in the ECG, can you not say how many heartbeats are there? Huh? Yeah. Number of waves is equal to number of heartbeats. Is equal to the number of heartbeats. Okay. Counting the number of complex, get about the heart. Okay. And here we can say RR interval, R to R interval is duration of one cycle. Okay. If heartbeats are more, I'm asking you questions. You tell me the answer. If the number of heartbeats are more, this R interval, the gap between 1 and R will be high or low, tell me. If is a RR interval increases or decreases?
Decrease.
Decrease.
Increase or decrease?
Decrease.
Decrease, sir.
Decrease. Some are saying decrease, some are saying increase. Who said decrease? Who said increase first? Raise the hands. Who said increase? Raise the hand. No one said increase? Or someone was saying increase. Acha, Balram said increase. Now explain why it will increase. Why the gap between two R will increase? Explain. Stop the share. Tell me why it will increase. You're saying that it should increase. Why? Fast. We don't have a whole day. No explanation. Just randomly increase or decrease. Who said decrease? Some people said decrease, na? Raise the hands. Who said decrease? That RR interval will decrease if there is an increased heart rate. Hare Sai Krishna, can you hear me? Some people were saying decrease, na? Who were there? I'm not asking you, I'm asking everyone. People who said decrease, please raise your hands. Now they think that sir will be asking explanation, so why to raise the hand? Kalyan Ram, you listen to the classes in the elite section, so you need not answer at all.
Okay, sir.
Others, except Kalyan Ram. Others.
Sir, question again.
Arey, I asked if there is increased heart rate. If there is increase in heart rate, the gap between two R waves means the ECG is PQRST, right? So two R wave we have seen, one cycle and another cycle. The RR interval will increase or decrease, I ask. Very simple.
Decrease, sir.
Why? Explain why.
Number of QRS means number of heartbeats, no, sir.
Okay.
Distance will also be.
Arey, that thing I know. I'm asking you why there will be a decrease in the distance.
Joint diastole will decrease, sir. Decrease, sir.
No. Let me ask another question so that with this question you can understand. If you can answer this question, you'll understand the answer for the first question. Second question, tell me, if heart rate increases, the duration of cardiac cycle will increase or decrease?
Increase, sir.
Sai Krishna says duration of cardiac cycle will increase. Anyone else? Achha, it will be constant. If heart rate increases, duration of cardiac cycle will be constant. Someone says constant. One Sai Krishna said increases. One Sai Krishna says constant. Yajat, you want to say something?
Yes, sir. Decreases, no, sir.
Decreases. How?
Per minute heartbeat, number of heartbeats increase, no, sir. If heartbeat, then cardiac
very
cycle
good. See,
time will decrease.
the duration of cardiac cycle, how did we calculate? In 1
Number
minute
of
we have 60 seconds. In 1
Yes,
minute
sir.
we have 60 seconds divided by number of heartbeat.
72.
So 60 divided by 72 to 75, we got 0.8 seconds. If heartbeat is increasing, in minute seconds will be same only or not? In a minute, second will be 60 only. 60, let us say your heart rate has become 100. So 60 by 100. What will be the value then? Cardiac cycle value? The
0.6.
time duration value? 0.6.
0.6.
0.6 is more than 0.8 or less?
Less, sir.
Less, na? So from this you can say na, the cardiac cycle duration will decrease. Now tell me, if the duration of cardiac cycle is decreasing, the time for atrial systole, ventricular systole and joint diastole all will decrease or not?
It's decrease.
Decreases. Okay. And in this ECG, see, in the ECG, what did we say? RR interval is what? The time duration between. What did we say? RR interval is the time duration between what? One cardiac cycle. It is the time of one cardiac cycle. So RR interval is duration of one cardiac cycle. So if heart rate is increasing, the duration of cardiac cycle is decreasing. So the gap between one hour and another hour will increase or decrease? It will decrease. All these things will come nearer. All the waves will become little bit closer. So the RR interval will comparatively decrease. And if I say that in one person's ECG, let us say that we have taken the ECG. Again, I'll just stop the screen share, just question. Okay, let us say one Harshvardhan who is flying in the air. So let us say we have tested Harshvardhan's ECG. We have taken ECG checkup for Harshvardhan. And once we observed the ECG, we saw that gap between the R and another R is more than 0.8. Means what do you understand from this?
Heart rate is less.
Heart rate is
Beat is less.
Less.
okay. So see, very easily you can know that with the help of ECG whether the heart rate is high or low. There are other things also that we can understand with the help of this ECG. Okay, how the heart is working, what problems are there in the heart, all those things we can understand with the ECG with respect to the change in the waves. Any change in the wave other than the normal wave represents certain defects of the heart. Those things we'll see tomorrow. because it will become very heavy for you to understand all the things today only. Those things we'll see tomorrow. Any doubts related to the ECG? The basic part of the ECG. Any doubts? No doubts?
Yes, sir. No doubts.
Once a screen.
No screens. No screen sharing, Sai Krishna. No screen sharing again. I told you, no, you should be attentive during the class so that you write whatever is being discussed. Maybe you are getting disconnected, or you are leaving, or you are not there. You just logged in and you left. No sharing of notes, no screenshots, nothing. Because if we enable those things, you will not attend the classes properly. Okay, then see you all later. Have a good day. Take care. Bye bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.